Hello. Today we will look at division of polynomials. And before we get into the whole division process, I just want to quickly remind you about two terms that we'll use, or two words we'll use a lot today in this video. One is a monomial, and as a reminder, a monomial is a one-term polynomial. We'll also look at a binomial, and a binomial is a two-term polynomial. So in the first part of the video, you will hear me talking about monomials, and uh, I just wanted to remind you what it is. Now remember, a polynomial uh, is consists of one or more terms. Okay, so we're looking at dividing polynomials. Okay, and when we divide polynomials, if the denominator is a monomial, then the division process is not very intense. Yeah. So we'll jump right into an example. Suppose I ask you to divide, let's say we have 25x to the 7th minus 15x to the 5th plus 35x cubed. And we'd like to divide this by here by 5x squared. So here, your divisor, the divisor, which is 5x squared, is a monomial. And it makes a big difference to observe this, okay? Because whenever your divisor is a monomial, we can rewrite the polynomial and separate them into terms. So this only happens when the divisor is a monomial. So since the divisor is a monomial, we can rewrite the problem by separating each term. And what I'm basically saying here is that we're going to separate the numerator, okay? So if we do this, we will get 27x to the 7 divided by my divisor, which is 5x squared, minus 15x to the 5th divided by the divisor, 5x squared, plus 35x cubed divided by 5x squared. So once again, this is only because your divisor is a monomial. Okay? Only because the divisor here is a monomial, a one-term polynomial. And then here now, we can divide each term. Remember, its term is separated by a plus or minus. So the first thing we can do, and I wrote 27, there should have been a 25. Okay. The first thing we'll do is, what is 25 divided by 5? And if 5 didn't go into 25 evenly, you would leave it as a fraction, okay? So 25 divided by 5 is 5, okay? And then now we have, what is x to the 7 divided by x squared? Well, you know when you're dividing and the base is the same, you subtract the exponent. So this becomes x, the numerator, minus the denominator. Yeah, I'm just writing it out since this is the first example, so you see what I'm doing. Then we have minus, okay, and once again, we have what is 15 divided by 5. And 15 divided by 5, if it goes evenly, we write 3. Now, since the bases are the same, right, x to the 5th, x squared, so that becomes x 5 minus 2. And we have plus 35 divided by 5. So 35 divided by 5 is 7. And for your variable, the bases are the same. So that becomes x 3 power minus 2 power. Now simplifying these here, simplifying these, okay, by simplifying those, we now have 5x to the 5th minus 3x cubed plus 7x to the 1. And if you recall, when we have a 1 power, we don't need to write it. So finally, we have 5x to the 5th minus 3x cubed plus 7x. And this here is the result of that division of polynomials. Yeah? That's our final answer. Now, pointing out to you, please note, or as a reminder, I should say, that the powers must always be positive, okay? If they're negative, you have to simplify further to make them positive. Let's look at another example. So we have divide. Say we have 8x cubed y to the 5th minus 16x squared y squared plus 4x to the 4th y cubed. And we want to divide all of this by negative 2x squared y. So once again, you will notice that your divisor here is a monomial, okay? So this here is a monomial. Anytime that divisor is a monomial, we can rewrite the polynomial. If we do this, we have, and I would strongly urge you to rewrite the polynomial. I'll show you a common mistake that occurs when we don't rewrite the polynomial. So we have 8x cubed y to the 5th divided by minus 2x squared y. Then we have minus 16x squared y squared divided by minus 2x squared y. And then we have plus 4x to the 4th y cubed over minus 2x squared y. And we divide as we did before. So what is 8? And it's a positive 8 divided by negative 2. So since this is a little positive there that we don't see, okay, here we have negative 4. Now, you notice we have two variables here. We have x, which bases are the same, and then we also have y, which bases are the same. So going straight ahead, if you subtract, this becomes x 3 minus 2, which is 1. And then we have y, 5 minus this invisible 1 there, becomes 4. Let's move to the other terms. We have now negative 16 divided by negative 2. And the negative divided by negative becomes positive. Okay? 16 divided by 2 is 8. Now, pay attention what will happen here. Okay? X squared, x squared. So we can either rewrite this as x to the 0, because 2 minus 2 is 0, and then y to the 1, because 2 minus that invisible 1. Or you will notice, because it's x squared divided by x squared, we can say they cancel out, right? Anything divided by itself is 1. And then you wouldn't have to write this here. So, but I will leave it as x to the 0 for now. If we move to our next term, we have plus 4 divided by negative 2, and that becomes negative 2. And then if we look at the letters, okay, x4 divided by x squared becomes x to the second. And then we have y cubed divided by that invisible y, the 1 there. So that becomes y squared. So rewriting and simplifying. So we have negative 4. We don't need to write the 1 there. So that's x y to the 4th plus 8. Now remember that x to the 0 is the same as 1, right? So we can write times. We could write times 1y minus 2x squared y squared. But 8 times 1 is really just 8. So the final answer is minus 4xy to the 4th plus 8y minus 2x squared y squared. So as you can see, when we were dividing, everything was working out fine. Yeah? Meaning that our 8 here is divisible by negative 2, and that's all my constant term were evenly divisible. In my next example that I'm about to show you, so example, what happens if they don't go out even? For example, if I have, let's divide, yeah, 10 a to the 4th b squared plus 8 ab cubed minus 12a cubed b plus 4a squared b squared. And all of that divided by this monomial, which is 4a squared b squared. Yeah. So once again, our denominator is a monomial. Okay. So all we have to do is rewrite this. Okay. Now here is the reason I urge you to rewrite. Because if we don't rewrite, a common mistake is that, just rewrite that. Sometimes what happens, notice that this term is the same as that term. And some people just cancel them out and say that this is the answer. And that's incorrect. Okay? So by writing it out, by rewriting it, okay, you don't do that. So let's rewrite this. Okay? If I rewrite this, I will have 10a to the fourth b squared divided by 4a squared b squared plus 8ab cubed divided by 4a squared b squared minus 12a cubed b divided by 4a squared b squared plus 4a squared b squared divided by 4a squared b squared. And now we can divide. Now 10 divided by 4. So that doesn't go evenly. So what I'll do is leave it as 10 over 4. Okay? And here we have a to the fourth divided by a square. So that becomes a to the second. And then we have b squared divided by b squared. So we can either say they cancel out, or we can write b to the 0. Okay? Then we have a positive 8 divided by 4, so that leaves me with positive 2. Now be careful here. We have a to the 1 power divided by a square, right? Keep in mind, there is an invisible 1 there. So when you subtract, this becomes a to the negative 1 power, right? 1 minus 2 is negative 1. And b, 3 minus 2 is 1. Okay? So I'm getting this negative 1 because it's a to the 1 power minus 2 power, which is equal to a to the minus 1. That's where I'm getting that from. Now, let's move on. So now we have a negative 12 divided by 4, which becomes negative 3. And we have our a cube divided by a square, which will leave me with a. Now, if you look at the next term, we have b divided by b squared. So keep in mind, there, when you see a letter, there's always a 1 exponent. So 1 minus 2, now we end up with b to the minus 1 power. And here is something else to pay attention to. Now, once again, some of you may say, oh, this cancels out, okay, because they're exactly the same. But remember, anything divided by itself is 1, right? So when you look at 4 divided by 4, you should write plus 1. And then anything divided by itself, we know is 1, right? So rewriting this, a few things to observe. This can be simplified. 10 over 4, you can divide top and bottom by 2, so we end up with 5 halves. Okay? A squared, b to the 0 is the same as 1, so we don't have to write it 1, plus 2. Now we have a to the minus 1. Remember, a to the minus 1 means 1 over a. And b minus 3a, b to the minus 1 means 1 over b plus the 1. And one more simplification, if you multiply all the tops, this becomes 5a squared, right? If you distribute or multiply, these are all over like invisible 1, so you can write that over the 2. Plus, same thing here, 2 times 1 is 2 times b, this becomes 2b over a. Same thing here, 3 times a is 3a times 1, so this becomes minus 3a over b. And then we have plus 1. And this here is our final result. So sometimes the coefficients is not divisible evenly, and you just write them as a fraction. And keep in mind, anytime you have a negative power, you have to simplify the negative power to make it positive. So that's very important for you. So I just want to point out to you here that the final answer, although you're dividing polynomials, okay, the final answer is not a polynomial, right? So this is not a polynomial because, and you will probably see it from this step here, okay? The final answer is not a polynomial because remember that polynomials must only have positive power. And if you look at your example, you have some terms with negative powers. Okay? So your final answer is not a polynomial because this is like a negative power. Just wanted to point that out to you. But in any event, that's our final answer. So now let's look at division by a binomial. It's still division of polynomial, but division when the divisor is a binomial. Okay? Binomial meaning a two-term polynomial. Your divisor is a binomial. So sometimes, so in general, we say that anytime it's a binomial or trinomial or any polynomial that's not a monomial, we have to perform long division. Well, that is true, but sometimes we can divide by factoring, okay? And it works out that way. And I'll do the example both ways to show you that the quotient, which is known as the answer, or the answer, which is known as the quotient, if you perform long division, it will also work. So suppose I said to divide x squared plus 7x plus 12 divided by x plus 4. Well, what I'm saying or what I said before, in some cases, okay, in some cases, you will be able to factor this numerator, okay? You will see that if you factor this example, it becomes x plus 3 times x plus 4. And if you divide that by x plus 4, now notice as when we did division, right? When we have the like terms, this term will cancel out with that term. So we have as our final result x plus 3. And here is our final answer. Now this will also work. You cannot separate as we did earlier because this here is not a monomial. Okay? This is not a monomial. So cannot rewrite. Now this happens This will definitely happen only when we can factor the numerator. And there are many examples, right, when this will happen, but it does not always work. And that's the reason why we have to learn what is called long division. Not very difficult, but you have to be careful with your algebra, the steps. So let's look at another example. Divide. If I have um, x squared minus 6xy minus 7y squared divided by x plus y. So notice, once again, this is not a monomial, so we either have to factor the numerator or we have to do long division. Well, if you look at this, yes, we can factor the numerator, okay? And that numerator can be factored into our as x minus 7y and x plus y, okay? So if you don't see this step from here to here, you can look back at the factoring video, okay, and see how we got to that step. Now, because this term is the same as that term, we can say that they cancel, and our final answer is x minus 7y. So this is the quotient or the answer. And once again, you were able to factor the numerator, okay? Now, what happens when we cannot factor the top? So, and I shouldn't say what happens when we can't factor the top. What happens when you don't see that it can be factored? Because probably when you looked at this example here, you probably didn't know that this can be factored, okay, by looking at it. If you did, that's good. You have, or you're good at factoring, okay? Or will get even better at it. Now, suppose I ask you to divide, okay, and I give you 2x squared minus 7x plus 9, and we want to divide that by, we're going to divide this by x minus 2. Yeah. So we're going to try this the long division. We will know at the end if that numerator can be factored or not. So remember, this here is your divisor. Okay? So that means when we set it up in a long division way, okay, when we set it up using long division, your divisor is what goes out here. Now it's important too to note that we fill in missing terms, right? We fill in our missing terms. And what do we mean by that? Well, if you look at the numerator, it's a x to the second power, x to the 1 power, then x here, there's no x here, so x to the 0 power. So that top is in descending order. If you had jumped from 2x squared to plus 9, then you would have to fill in this here as a 0x. They're called placeholders, so you will have to do placeholders when we have missing terms. And I'll show you an example. And then 2x squared minus 7x plus 9. Okay? So here is what I would suggest. Okay? There are many ways to explain this, but I think we'll go straight for the maybe easiest or shortest explanation. Okay? So the first thing I'm going to do, I'm going to do some scrap work. Okay? And what I'm going to do is take the first term on the inside and the first term on the outside. So, and that's what I'll divide. What is 2x squared divided by x? And if you do that, this becomes 2x. Now notice it's 2x to the first power. So I will write that above my like term, which is the minus 7x, because that has the first power. So this becomes 2x. Ignore the rest of the problems. Don't worry about it. It works itself into the problem. So ignore that minus 2, the minus 7x, and the plus 9. Now what I'll do, okay, is multiply. I'm going to multiply this 2x by everything here. So 2x, okay, times x becomes 2x squared. 2x times x becomes 2x squared. And then 2x times minus 2 becomes minus 4x. Okay? So now what I do. So be careful here because this is a step you'll have to remember. Whenever you perform long division, you always subtract here. So you will have to subtract this. Now, if you get rid of that parentheses and distribute this negative, this becomes a negative, and this here will become a positive because a negative times a negative is a positive. So generally what we say is to change the signs of each term, okay? So we don't show all of this working here, the distributing and this here. What we generally say is as you distribute, 2x times x becomes 2x squared, 2x times minus 2 becomes minus 4x, and then we say this is a plus, we change the sign. So rather than this being a plus, it becomes a minus. Rather than this being a minus, it becomes a plus. And now we combine like terms. So minus 7x plus 4x becomes minus 3x. Plus 2x squared minus 2x squared, these two terms cancel out. Immediately after you finish, you must bring down. And then we repeat what we did again. So we go back to our scrap work and we said the first term divided by the first term. So what is minus 3x divided by x? And now the x's will cancel out. That leaves me with minus 3. So we take our minus 3 and we write it over the plus 9. And then we do the same thing. Minus 3 times x and then minus 3 times negative 2. Okay? So if we do this, minus 3 times x will give me minus 3x. And minus 3 times negative 2 will give me plus 6. Okay? Now don't forget, we have to change those signs. So this minus is going to change to a plus, and this plus is going to change to a minus. And if we do this, we have 9 minus 6, which is 3, and this minus 3 will cancel with that plus 3. And there is nothing else to bring down, so that 3 is my remainder. Okay, this here is my remainder. Now, because you end up with a remainder, okay, because you end up with a remainder, it means that that polynomial that you started out with earlier, this polynomial here could not be factored. Okay. If you had no remainder, it means that it could have been factored. So you have 2x squared minus 7x plus 9 over x minus 2. This is equal to the quotient here, which is 2x minus 3, and always plus the remainder, which is 3, over your divisor x minus 2. And this is our final result. Notice here that this is your divisor, so the remainder always goes over the divisor. And there is another way of writing this also, okay? There's also another way of writing this, which for now, I don't want you to pay attention to that, but there's also another way of writing it. If you're taking a pre-calculus course, then there's other ways of writing this. If it's an intermediate algebra course, then you can leave your answer like that. Okay. Let's look at another example. Divide. We have 4x cubed minus 6x minus 11. All of this divided by 2x minus 4. So notice that this is a binomial, okay? Binomial. So you have to do long division, okay? Now, if you look at this top term, we have missing terms, okay? There's an x squared term missing. So what we have to do is 4x cubed, and it's always when you fill in a missing or placeholder, right? Placeholder, always a plus. So 0x, let me write that in a different color, okay? Plus 0x squared, okay? Minus 6x minus 11. So the reason I did this is because you have a 3 power, a 2 power, a 1 power, no power. And that's what we should do for both numerator and denominator. On the denominator, we have 2x to the 1 power, okay, minus 4x to the 0 power. So it's just a constant. And when you set up your division, this is the way we should write it. So my divisor is 2x minus 4, and that what goes on what I say the outside. So we have 4x cubed plus 0x squared minus 6x minus 11. And don't forget, we have to do some scrap work, right? The scrap actually will help you. So the first term on the inside is 4x cubed. The first term on the outside is 2x. And if you do this division, this becomes 2. 4 divided by 2 is 2. X cubed divided by x is x squared. So I will write this x squared term above the x squared term, which happens to be the placeholder. Okay, so this becomes 2x squared here. And then remember, we distribute. So 2x times 2x, okay? 2x times 2x, and then 2x squared times 2x, and then 2x squared times minus 4. When we do this distribution, okay, this will becomes 4x cubed minus 2 times 4 is 8x squared. And don't forget, okay, we have to change the sign. So this plus changed to a minus, and this minus changes to a plus. So 0x squared plus 8x squared becomes 8x squared. Plus 4x cubed minus 4x cubed, these two terms will cancel. Immediately after you combine, you must bring down. Okay? And then don't forget we have the minus. The next step will bring down the minus 11, or if you want, you could bring it down now. It doesn't matter. So scrap work again. 8x squared divided by 2x. That becomes 4x. Right? It's a positive, so we write positive 4x. And then we distribute 4x times this, and then 4x, oops, 4x times this, and then 4x times that. Okay, 4x. If you do that division, or that distributing, sorry, you will get 4x times 2x is 8x squared, and 4x times minus 4 becomes minus 16x. Did I add a 16 above before? Okay, no. Don't forget, this is a plus here, so you have to change your signs, okay? So when you change your sign, this becomes a minus, and this becomes a plus. So minus 6x plus 16x becomes positive 10x, and plus 8x squared minus 8x squared will cancel out. And now before you do anything, don't forget you have to bring down. And then we do our scrap work again. So we have 10x divided by 2x, and that becomes 5. The x's will cancel out. So we have a plus 5 here. And then we distribute. 5 times 2x is 10x, and 5 times minus 4 becomes minus 20. Don't forget, okay, we have to change our signs. So this now becomes a minus, and this becomes a plus. So minus 11 plus 20 becomes positive 9, and plus 10x minus 10x, these cancels out. So here again we have a remainder. Okay? So we can say that the final answer is 2x squared plus 4x plus 5 plus your remainder, which is 9, over the divisor, which is 2x minus 4. So this is your quotient, okay, also known as the answer. So sometimes you will get remainder, sometimes you don't get remainder. Now, how about it? Remember the very first problem I did, right? The very first problem I did was x squared plus 7x plus 12 over x plus 4. Because sometimes we are thinking about our work and we don't see when things can be factored. Because in this example, I factored the numerator and I got x plus 3, x plus 4. Okay, and sometimes we don't see that. So let's do back that example and do it long division now and see what will happen. Right? So my next example, divide x squared plus 7x plus 12 divided by x plus 4. So once again, my divisor here is a binomial. So anytime it's not a monomial, we can perform long division. So if I set this up, we have x plus 4. And there are no missing terms in the numerator, so we have x squared plus 7x plus 12. Okay. Now, remember, scrap work, very important, scrap work. So the first term on the inside is x squared, the first term on the outside is x. And if I do this, I'll have an x term. So I write the x term above the x term, so that goes here. Then I distribute x times x times 4, right? That's the next step. So x times x becomes x squared, x times positive 4 becomes positive 4x. Don't forget, we have to change the signs. So this plus becomes a minus, this plus becomes a minus. They always change to the opposite. So 7x minus 4x becomes 3x. Plus x squared minus x squared cancels out. And before you do anything, you must bring down. And then we repeat the process again. Scrap work, 3x divided by x, and that leaves me with 3. The x's will cancel. So I write plus 3 in the top. And then I distribute again, 3 times the x, 3 times the 4. By doing this, 3 times x I have 3x positive, and 3 times 4 I have positive 12. Don't forget, you have to change those signs to the opposite. So 12, positive 12 minus 12 is 0. My plus 3x and minus 3x is cancelled. And there's nothing else over here to bring down, so that's the end of my problem. Now notice you have a 0 remainder, okay? And I said to you, if you have ever divided and get a 0 remainder, it implies that this here, okay, could have been factored, and which we saw before. So our answer here, x squared plus 7x plus 12 divided by x plus 4 is equal to x plus 3. And notice that this is exactly what we had when we did our very first example. Okay, the answer here, x plus 3. And we knew that this could have been factored because when we do it long division, we have a 0 remainder. Okay, 0 remainder. So anytime you have like a 0 remainder, it just means that polynomial, okay, has been factored. That's all it implies. Let's look at another example. So divide x squared minus 6xy minus 7y squared divided by x plus y. Okay? So let's focus on the x term here. So we have an x squared, okay? Then we have an x to the 1, and notice there's no x term over here, x to the 0. So it seems like there's no missing term here. So I'll go straight and set up my division. So x plus y, that's my divisor, and x squared minus 6xy minus 7y squared. Okay. And we do our scrap. Okay. So the first term on the inside is x squared, and the first term on the outside is x. And x squared divided by x is x to the 1 power. So I write it above the term with the x to the 1 power. So I will put it right here. Okay. And then if you multiply as we did before, right? We're going to multiply as we did before. So by doing this, x times x becomes x squared, positive, and x times y becomes plus xy. And don't forget, you have to change the signs to their opposite. So minus 6xy minus xy becomes minus 7xy. Okay? Plus x squared minus x squared cancels. And immediately after you finish combining, you must bring down. And then we have scrap work again. Scrap minus 7xy divided by x. Okay? Always the first term by the first term. We don't care about the plus y, we don't care. When we distribute, we work with that. Okay? So you're not leaving out anything. And this becomes, the x's will cancel out, minus 7y. Okay? So minus 7y. And if I distribute here, if I distribute this times this and then this times this, so minus 7y times x minus 7y times x becomes minus 7xy. And then minus 7y times y becomes minus 7y squared. Okay? Don't forget, we have to change our signs. So if we change this to its opposite, which becomes a plus, and this to its opposite, which becomes a plus, we have minus 7y squared plus 7y squared, that is 0, and minus 7xy plus 7xy cancels. So the remainder is 0, meaning that if we had tried to factor that numerator, it would have been able to factor. So we have x squared minus 6xy minus 7y squared divided by xy is equal to x minus 7y. And here is our answer when we perform the division. Let's look at one more example. Divide x cubed plus 9x squared plus 26x plus 24 divided by x plus 2. So we look for missing terms in the numerator. We see there's a 3 power, 2 power, 1 power, x to the 0, which is 1. So the numerator has no missing term. Also check the denominator. The denominator has no missing term. So we can go ahead and we can set this up. Okay. X plus 2 and x cubed plus 9x squared plus 26x plus 24. So we do some scrap work. Okay. We do some scrap work. Actually, let's write this on a new page. X plus 2, we have x cubed plus 9x squared plus 26x plus 24. And then we have our scrap. First term on the inside is x cubed, first term on the outside is x, so that leaves me with x squared. So I write it above the x squared terms. Okay. And then I distribute the x squared to the x. Okay. So this becomes x cubed, it's positive. X squared times 2 becomes plus 2x squared. And don't forget, I have to change my sign. So this becomes a minus, this becomes a minus. 9x squared minus 2x squared is 7x squared. The plus x cubed and the minus x cubed cancel. Immediately after you combine, you should bring down. So we have our scrap again. Scrap will be 7x squared divided by x, and that gives me 7x. So we write plus 7x. And then when we multiply, 7x times x becomes 7x squared, positive, and 7x times 2 becomes positive 14x. As a reminder, you have to change the sign. So that's a minus, that's a minus. So 26x minus 14x becomes positive 12x. And the plus x 7x and the minus 7x squared cancels out. As soon as you finish, you bring down. And then we do our scrap work again. So we have 12x divided by x, and that becomes the x's cancel out plus 12. So we have a plus 12 here. And if you distribute that 12, 12 times x becomes plus 12x, and 12 times 2 becomes plus 24. Don't forget, we have to change our sign, so this becomes a minus, that becomes a minus, and we have 0. So this means that x cubed plus 9x squared plus 26x plus 24 could have factored. Okay, so what do we have? It's telling me that x cubed plus 9x squared plus 26x plus 24 divided by x plus 2 is equal to x squared plus 7x plus 12. Now here is something that I should point out, and I want you to pay very close attention to this. Okay, your remainder is 0. Okay, so when your remainder is 0, it means x cubed plus 9x squared plus 26x plus 24 could a factor. It also means, right, so 0 remainder tells two things. One, okay, your dividend, the dividend, which is x cubed plus 9x squared plus 26x plus 24, could be factored. And two, which is very, very important for you, it tells us that x plus 2 is a factor of the dividend x cubed plus 9x squared plus 26x plus 24. And this one here is very important with the way the problem is worded. Okay, so this also tells me that if I had taken, okay, x cubed plus 9x squared plus 26x plus 24 divided by x plus 2, and if I know that this here is a factor, I could say x plus 2 times x squared plus 7x plus 12. If you multiply these two things, you will get back this. Okay? Now, this here is also quadratic. Okay? So you can factor that we did x squared plus 7x plus 12. So this portion, right, x plus 2 times x squared plus 7x plus 12, later on, this can also be factored as x plus 3 times x plus 4. We just did that. So if you were able to factor that dividend, then all of the factors would have been x plus 2, x plus 3 times x plus 4. So long division will help you to find the factors of the polynomial, because you should be very proficient of how to factor quadratic. Okay, you may not be proficient of how to factor a cubic, but by knowing a factor, you're able to break that cubic down into a quadratic. Okay, every time you perform long division, the dividend degree decreases. Okay, so if you're dividing a cubic by a 1 degree, your answer will be x squared. Okay, so the degree decreases always. Okay, so a few more practice when you should become better at this, and I always urge you to always try additional practice problems.